Ever thought about how different our solar system might have looked in the past? Were the planets anything like what we see now, or could they have been unrecognizable? Well, get ready, because in today's video, we're going on a journey back in time to explore what our planets were like a whopping 3.8 billion years ago. But wait, why did we pick this specific time frame? The answer is simple. Around 3.8 billion years ago, our solar system was coming out of a fascinating era called the Late Heavy Bombardment Period. This window of time, lasting from 4.1 to 3.8 billion years ago, witnessed a cosmic fireworks show of sorts. Yep, you guessed it. During this period, there was a flurry of asteroid impacts bombarding the planets and other celestial bodies within the inner solar system. So grab your space helmets, because we're about to embark on an incredible voyage to uncover the mysteries of our solar system's past. But don't forget to like and subscribe to the channel. Shifting gears a bit, folks. We usually start by delving into the planets closest to our solar star. But today, we're flipping the script because we've got something special in store. Get ready, because when it comes to the gas giants, Jupiter, Saturn, Uranus, and Neptune, they've been holding on to their looks for quite a while. Curious why? Well, it all boils down to the fact that these giants don't sport solid surfaces like our rocky neighbors do. You might be wondering, what about the late intense bombardment period? Believe it or not, these massive planets didn't escape the asteroid onslaught entirely. Back then, Jupiter, Saturn, Uranus, and Neptune were like giant cosmic bullseyes, attracting their fair share of asteroid impacts. But here's the twist. Those impactors just dove straight into their thick cloud layers, leaving the planet's overall appearance pretty much unchanged. Now let's talk about a potential color makeover. Some astronomers propose that the minerals from those visiting asteroids might have subtly tinted the gas giant's clouds over time. Think about it, a cosmic paint job. The idea is not entirely off the mark. Take the case of Comet Shoemaker-Levy 9, the celestial cannonball that smacked into Jupiter back in '93. This comet unleashed a trove of material, crafting a deep, dark vortex on Jupiter's surface. This impact altered the clouds ever so slightly and gave astronomers a hint about what might happen with mineral deposits. However, beyond these minuscule changes, it's safe to say that our gas giants have mostly retained their familiar appearances throughout the eons. But here's where things get captivating: their moons. Brace yourself for some moon mysteries. Back in the day, it's entirely possible that the gas giants weren't as moon-blessed as they are now. Take Neptune and its showstopper, Triton, for example. The tale goes that Triton wasn't always Neptune's moon. It was an independent celestial wanderer, but Neptune's gravitational charm proved irresistible, and it nabbed Triton, pulling it into its orbit. So there you have it, an inside scoop on our gas giant's timeless looks, and a teaser about the captivating story of Triton and Neptune. Stay tuned for more mind-blowing cosmic revelations. Mercury. Shifting our focus from the gas giants, we now journey to the rocky planets. And trust me, things looked vastly different. Starting with Mercury, picture this. 3.8 billion years ago, it resembled a blazing cauldron right after the Late Heavy Bombardment Period. Messenger probes' thorough scans revealed Mercury's surface akin to the Moon's, adorned with countless meteorite impacts, ranging from a few meters to thousands of kilometers wide. Some craters are relatively young, just a few million years old, boasting central peaks. However, older craters suffered immense erosion, possibly due to wild temperature swings, scorching 623 Kelvin, 350 degrees Celsius, days followed by icy 103 Kelvin, minus 170 degrees Celsius, nights. Like the Moon, Mercury took a beating around 4 billion years ago when massive meteorites pummeled its surface. The lack of atmosphere allowed these cosmic rocks to hit without restraint. During this fiery era, Mercury was also volcanically active, spewing lava to create plains akin to the Moon's seas. Messenger probe hinted at possible volcanoes. Mercury's plains are dual-aged. Newer ones bear fewer craters, formed as lava flows covered prior terrains. Curiously, the surface showcases numerous compression folds, likely stemming from the planet's interior cooling and contracting, leading to surface deformation. These folds appear atop craters and plains, indicating their relative recency. And here's a twist. Mercury dances to the sun's tidal tune. The Sun's tidal forces on Mercury are 17% mightier than the Moon's on Earth, significantly shaping its surface. One of Mercury's geologic marvels is the Caloris Basin, an impact crater of epic proportions spanning around 1550 km, previously thought to be 1300 km. It's home to an enigmatic formation called the Spider, a cluster of about 100 fissures on smooth ground encircling a central crater. Their origin remains a mystery. All these puzzle pieces tell a tale of Mercury's tumultuous past. With countless meteorite and comet collisions, it's likely that the planet once resembled a blazing inferno, quite different from its current appearance. Venus. Venus, the solar system's hottest planet with its sulfuric acid rains and temperatures soaring beyond 480 degrees Celsius, was not always the scorching inferno it is today. Evidence suggests that billions of years ago, Venus closely resembled Earth. After a period of meteoric bombardment, numerous comets and reservoirs of ice collided with Venus and other rocky planets. The impact melted the comet's icy content, resulting in water that, with sufficient gravity and atmosphere, could have formed oceans, lakes, and rivers. Scientific consensus indicates that Venus once had a milder climate and atmosphere, with temperatures around 50 degrees Celsius, far friendlier compared to the current extreme. During an estimated 300 million years, Venus likely retained the water from cometary collisions and maintained a carbon dioxide-rich atmosphere. However, a gradual shift occurred. Increasing carbon dioxide levels led to rising temperatures, causing water to evaporate and eventually vanish. Over time, Venus underwent a relentless greenhouse effect, trapping heat and exacerbating the atmosphere's greenhouse gas content. This transformation turned the erstwhile placid, water-endowed planet into the solar system's hottest realm. The unforgiving heat-trapping mechanism led to surface temperatures that deterred any possibility of life taking root. In its tumultuous journey, Venus serves as a cautionary reminder of the delicate balance between climate, atmosphere, and habitability. The Earth. Earth, undoubtedly the most distinct of planets, hasn't always been the serene blue heaven adorned with lush forests and oceans teeming with life. Approximately 3.8 billion years ago, post the late bombardment phase, Earth bore a markedly different visage. It was in the nascent stages of the Archaic era, marked by crustal evolution and incipient plate tectonics, a structural semblance to today's arrangement, albeit with excess heat. During this period, they showcased heightened seismic upheaval due to rapid lithospheric generation, fostering significant activity along submarine ridges propelled by tectonic shifts. Subduction zones were intensely dynamic, characterized by numerous smaller plates, triggering ceaseless planetary earthquakes and widespread volcanic activity. The atmosphere contained elevated greenhouse gases, predominantly carbon dioxide, while oxygen remained scarce. Despite this, temperatures neared modern levels, with liquid water evident even around 500 million years post-Earth's formation. This era coincided with a solar luminosity of around a third of present levels, possibly contributing to cooler global temperatures. This epoch marked Earth's zenith in greenhouse gas concentration. It birthed stromatolites, fossils of cell colonies that shaped sedimentary rocks, commencing 3.7 billion years ago and flourishing around 1.25 billion years ago. These organisms ingeniously converted carbon dioxide into oxygen, infusing the atmosphere with the life-sustaining gas we now rely on. The Earth then lacked the hospitable conditions for contemporary life forms. Most existing species would have struggled to survive these formidable conditions. Mars. Let's turn our attention to Mars. Scientists posit that Mars bore a striking resemblance to Earth in its earlier days. Much like Venus and Earth, Mars underwent a phase of comet impacts following the late bombardment period, which infused the planet with water. As a result, Mars boasted a denser atmosphere than its current state, coupled with agreeable temperatures and vast bodies of water, including oceans and rivers, creating conditions conducive to hosting life. Recent exploration probes have uncovered telltale signs of former water flows on the red planet, alongside pockets of water intermingled with sand or clay beneath the Martian surface. Mars was undoubtedly a more accommodating abode for life in its past. Some scientists speculate that life might have originated on Mars and potentially journeyed to Earth through asteroid transport, a notion aligned with the panspermia theory. For a considerable duration, Mars surpassed Earth as the more habitable planet, boasting superior conditions for life. Yet, its diminutive core led to rapid cooling, causing the loss of its magnetic shield. The absence of this protective field, coupled with feeble gravity, left Mars vulnerable to solar radiation and the erosive effects of solar wind. Gradually, the planet's atmosphere was stripped away, diminishing atmospheric pressure, evaporating water, and transforming Mars into a desolate, arid realm. This journey through planetary history underscores profound transformations that shaped their present states. Amidst these narratives lies the story of a planet that secured the essential prerequisites for life. Examining the past has granted us insights into the future. We acknowledge Earth's ongoing evolution and its impermanence as a hospitable habitat. This realization compels us to cherish and safeguard our home planet, while contemplating the prospect of establishing new havens among the stars. Have a suggestion for a future video? Share your valuable insights with us in the comments section.